Hi everyone! In this video I'm going to show you how to handle angles in parallel lines as well as angles in triangles, sort of an extra skill. So the big idea with parallel lines is parallel lines are lines that go in the exact same direction. So for instance, on this first example here, we have that this line is parallel to this line. And we usually draw it with these sort of arrow going through symbols. So if you look down here, like we've got an arrow going through symbol here and an arrow going through symbol here, that means that those two lines are parallel. And we've got like a double arrow here and a double arrow here to indicate that those two lines are parallel. Now the cool thing is about these parallel lines is when you've got a line crossing, it's called a transversal. It doesn't really matter what it's called, but that's called a transversal. And if you've got a line crossing both of your parallel lines, you should just be able to eyeball it and notice that this angle here, let's call that A, I guess. That angle A is the acute angle. Well, that acute angle is the same as this acute angle here. And it's the same as this acute angle here. And it's the same as this acute angle down here. So angles across an X from each other, like here and here, they make the same angle. And normally I show this, by the way, at this point, I don't have video on me, but I'd be waving my arms through the air, showing you that as I swing my forearms across each other in different angles, no matter what angle I put my forearms, the angles across my forearms are always the same. Angles on either side of an X are always the same as each other. So those two are the same, and those two are the same. And the same thing is true here. So this acute angle and this acute angle are the same. This acute angle and this acute angle are the same. Now we also have an obtuse angle. I guess we'll use T for obtuse because I don't really like O as a variable. So let's call that the obtuse angle. And we can get T from subtracting from 180, right? 180 minus A gives us T. And vice versa. 180. Okay, it's not working. There we go. 180 minus T. Okay, there we go. Don't know why things not working. 180 minus T gives us our acute angle A. Okay, because they are supplementary to each other because they made it a straight line. But that one obtuse angle is going to be the same obtuse angle here, the same obtuse angle here, and the same obtuse angle here. So which angles are the same? All four acute angles and all four obtuse angles. And that's true anytime you've got a line crossing two parallel lines. What is the connection between the angles? They are, what's it called when two angles meet at a straight line? They are supplementary. And we learned in the last lesson how to calculate supplementary angles, which is this 180 minus business, right? And with just those two skills, we can actually solve some interesting things. So looking at this diagram here, let's solve for all the missing angles. This here is my obtuse angle of 95 degrees. So anywhere I've got an obtuse angle, A is 95 degrees, which means that C is also 95 degrees. And this angle here is also 95 degrees. You'll notice that all of those are obtuse angles on the left-hand side. And that's using the fact that these two lines are parallel. But we also have that these two lines are parallel, which means that this is also the same 95 degree obtuse angle. And this is the same 95 degree obtuse angle. And this is the same 95 degree obtuse angle. And this is the same 95 degree obtuse angle. All of those obtuse angles everywhere in this diagram are all 95 degrees. Now, all of our acute angles are going to be the same as well, but we're going to have to do just a little bit of work. 180 minus 95 is 180 minus 95, 85 degrees. So this is 85 degrees, this is 85 degrees, this is 85 degrees. All of our acute angles are 85 degrees because we have parallel lines everywhere. So this seems a little bit silly, but this actually comes up a lot. Often you're building scaffolding and structures and things like that. And knowing that the angles are the same all the way up your scaffolding, all the way up your structure, what you've got like you're building, I don't know, cross braces or whatever that are going up like roof struts or whatever. Knowing that those angles are the same all the way up is really useful. And if it's symmetrical, they'll be the same on the other side as well. but it won't necessarily be symmetrical. So let's look at this example over here, ABC. So we've got a triangle with parallel lines. There's one other skill we need to know for this. We need to know that angles in a triangle sum 180 degrees. So if you've got two angles in a triangle, you can solve for the missing angle by subtracting from 180 degrees. And we'll get to that in just a sec. So I know that this angle over here is 142 degrees, which means that the angle across from it, right, angles across an x are the same as each other. So this is also 142 degrees. And C is also 142 degrees. And I suppose if I extended this line down here, then we could figure out that this angle down here is 142 degrees. But it's not labeled, so let's not complicate things. So those three angles are all 142 degrees. Now, how can I find this angle in here? Well, it's supplementary to 142. So let's call that x. So 180 minus 142 gives us 180 minus 142 gives us 38 degrees. Can we zoom in a little bit? If I can. There we go. Okay. So this here is 38 degrees. Now, a lot of students find this kind of confusing, the idea of having a line crossing this way, our two parallel lines, is different from the line crossing our parallel lines this way. Except that on the left-hand side, we've got another angle that's labeled for us. We know that that's 90 degrees. If that's 90 degrees, then this is also 90 degrees. And what happens when 90-degree angles meet in a straight line? Well, they're both 90. That's 90, which means that's 90, which means this is 90 and this is 90. And so all that we're left with, let's see, what angles do we not know yet? We don't know this angle up here, B. We don't know this angle down here, A. And we don't know either of the angles over here. Oh, except we do. We do. This 38 degrees here is the same as this 38 degree angle here. Those are both 38 degrees, right? Because like we could have calculated that from the straight angle. This is 180, right? 180 minus 142. Or we could use the fact that they're the same acute angle within the parallel lines, if you see that connection. Okay, so we know that angle there. We don't know this red angle. We don't know this brown angle. Now, let's figure out this angle up here, this angle B. So this angle here we can get from the angles in a triangle sum 180 degrees. So what that means is, if you know two angles in a triangle, you can always get the third by doing 180 degrees, which is the three angles in a triangle. And then we can subtract the two angles we know. We know that one angle is 38 degrees. We know the other angle is 90 degrees. So we can just do 180 minus 38 minus 90, and we can get 52 degrees. Okay, so B is 52 degrees. Now this one down here, it's tempting to think we can solve for, but we actually don't know what angle this line is. Like that line there could be going like this, or it could be going like this, or it could be going like this. There's no way in knowing from the diagram what angle this line is actually going at. And so these last two angles we can't solve. We cannot solve. And that's okay too. Sometimes you're going to get diagrams where you can't solve for everything. And that's okay. You just need to use your rules carefully and go through and solve as much as you can. And if you only know one angle in a triangle, then you can't solve for two unknowns at once. You can't solve for two missing angles in one step. Oh, sorry, not those two. We wouldn't know those two. Okay? You just can't do it. Okay, and that's angles and parallel lines. And so here are the practice questions. Okay, have fun with it. I like parallel lines. They're kind of like little angle puzzles, I think. I kind of like them. You can do them in different orders. You can do whatever you like. You're going to be using your supplementary angle rule quite a bit, 180 minus the angles, and you're going to be using your matching angles across parallel lines quite a bit. And in these triangle questions, you're also going to be using your angle in a triangle step, 180 minus minus. Okay, have fun with it, and good luck.